funny that I have a note on my computer to start the recording, so of course I forgot. All right. So anyway, this is our mission. We're all about Azure. We try to mix it up. We try to have developer topics and infrastructure topics, and really kind of, like last month, I think we had a chat GPT presentation, which was kind of interesting. This is our history. We were actually founded way back in 2013 with 4 people, and now we have over 2,000 registered members. But we still could use more members, so tell your friends and coworkers about us. We're currently meeting online only. We used to meet in person, and we used to meet in a hybrid mode, and we may go back to that at some point, but right now we're still just meeting online. This is our agenda. We usually start with an overview of the group, and then I'll do that. I'm doing that now for about 10 minutes, and then the main meeting topic. But let us know what topics you're interested in. And if there's an Azure related topic that you'd like to present, let us know. Okay. Board of Directors is myself. I'm the founder and president. I'm an Azure Solutions Architect. Roger Dahlman's co-founder and vice president. He's an enterprise architect at Deloitte. Tim Warner, who I'm sure most of you know, I guess I have to update this. He's actually left Microsoft and gone back to Pluralsight. So this slide has to be updated. And Jack Fagler is our technology associate director, he's a technology associate director, and he's been providing us with pizza when we meet on site, and he's actually providing the Zoom subscription. Again, Microsoft also pays for our meetup dues, which is nice. Vaco provides the Zoom subscription. And then we have a couple of sponsorships, the Greater Nashville Technology Council and A Cloud Guru, which is our training sponsor. We don't have any special deals with A Cloud Guru yet, but we're working on setting something up with them. Again, if you'd like to have your company like to get some publicity by spending 10 or 15 minutes at the beginning of this meeting promoting your company, let us know. In the past, we've handed out gift certificates, swag, anything that can be raffled off. So just contact Roger Dahlman if your company wants to participate. We've got a YouTube channel where we'll post this. We'll post this recording within a day or two after the meeting. And of course, we have openings for future meeting presenters. So let us know. And if you know someone that we should invite to present, let us know that as well. Anyway, I'm going to start tonight's meeting. Tonight's meeting is Azure Container Apps, and our presenter is Douglas Starnes. Douglas is a Microsoft MVP, a professional explainer of Python, AI, and cloud. And with that, I'm going to turn the presentation over to Doug. Let me stop sharing. Doug, can you share?
Yes, I can.
Okay.
Share. Okay, I'll start my.
All
right. Well.
Oh, there we go.
Okay. Can you see my PowerPoint?
Yes, I do. It's just
okay, great.
Container.
Because I don't need to see it over here.
Get this out of the way. Azure Container Apps. We see it.
Yes. All right. So, good evening, everyone. Thanks for joining us tonight. I'll try to keep this to about an hour. I've got roughly half and half slides and demo. One thing, if you will indulge me, I would like to, however, plug a few things. So the first one is my Python user group, which meets the third Monday of every month. And so that's actually coming up this Monday, 6 p.m. It's virtual via Teams. Let me see here. Is there a chat? Yeah, there is. Here's the shortened link to it. I just posted it in the chat there. I'm actually going to be talking this month. I just finished a Pluralsight course about working with Python 3 and databases, and so I'm going to be doing some excerpts from that. So that'll be, so feel free to join us if you'd like. A couple of conferences that are coming up that the CFPs are still open for. One is DevSpace, which is run by my friend Chris Gardner in Huntsville, which is even closer to which is closer to those of you in Nashville than it is to me. I'm in Memphis, and it's going to be October 23rd and 24th, if I'm not mistaken. That is a Monday and Tuesday. Um, but at any rate, this is a really this is the first time that this has met in person for 3 years now. So anxious to see that come back. It's in a nice facilities. There's an embassy suites that's connected to the facility that I assume will be the conference hotel again. And I don't know how long it's open. Oh, it's open for, yeah, you're gonna leave it open. Yeah, you said it was gonna leave it open for a month. So starting today, and it'll open. So you got a little bit of time. And then finally, when you've got about 5 hours for this one, Connect Tech. This is run by my friends Pratik Patel and Vince Mayers in Atlanta, and that's actually going to. It actually overlaps a little bit with DevSpace, but this is a front end conference. So lots of, they say it's front end, but it's largely JavaScript, mobile. But there's lot of different topics. Like I said, this one. I've been to both of these conferences multiple times. They're fantastic. Know the guys who run them. They always do a really good job. But like I said, this one you got about 5 hours because today is the last day for the CFP. All right. So there's the Azure portal, which we'll come back to later. And I'll go back to the slides. So tonight I'm going to talk about Azure Container Apps. And what I'm going to do is I'm going to talk about a little bit about a couple of prerequisite topics, and then we'll discuss um, kind of how Azure got started in containers, and then some of the other options for running containers on Azure. Because what you're going to see is that these different services, they complement each other. And then we'll do a demo, and not too complex of a demo, but something at least to see how to get you started. And also then we'll take a look at some of the stuff that's in preview that's coming up next. So first of all, you need to know about containers, and that fade transition. I forgot to take it out of the slide deck. I thought Pluralsight had broken me from using the fade transitions. But at any rate, containers. So the reason why we have containers, this will be review for some people, but however, is that before containers we use virtual machines. And virtual machines are just really heavyweight. Because what you're doing is you have you have an operating system and all of the resources essentially that go along with it. So they're slow to start up and provision. They're expensive to run. You have if you have multiple virtual machines, you have lots of duplication of resources among those machines, such as CPU, memory, disk storage, that may be wasted depending upon the size of your application. So like I said, so you may be wasting a lot of resources if you're using virtual machines instead of containers. So there's this thing. So somebody came up with this idea. I forget. I don't know exactly who, but however, this idea of a container. What we're going to do is we're going to package this application in a lightweight wrapper, and we're only going to include what is needed for that application. So things like just the code, the runtime, any dependencies or libraries, configuration settings. And what we're going to do is we're going to package that. We're going to put that into something called a container image. And then the container is actually an instance of the container image, kind of similar of how a class is an instance of an object. And because they're so lightweight, they are super fast. You can start them in just a few hundred milliseconds sometimes, depending on, if you can tune them or depending on the size or what it requires. Because of this offers several advantages, and one of them is that they're very scalable. You can spin a whole bunch of these up, and it doesn't cost you a whole lot to do it. Also, reducing development issues. So one of the things is portability. You may have heard of the works on my machine seal of approval. When your application runs just fine in the development environment, but you deploy it to production and it completely breaks on the server. You don't have that problem as much. It's not an absolute, but the container does relieve that problem somewhat, because you have the same container host on your development machine that you have on your in your deployment environment, your production environment. So essentially, you're targeting the same runtime in both. Fantastic for microservices. I'm not going to. I don't have examples of microservices tonight. If you're interested, we can talk about that later. But one of the things that you're going to see is if you go through the documentation of any container service, not just container apps, but that they're fantastic for developing microservices because they're scalable, because they're very small, they're very fast and lightweight. And also you've got tools like Kubernetes, and we'll hear quite a bit about Kubernetes tonight. We're not going to talk specifically about Kubernetes, but Kubernetes, which is a container orchestration and management platform. The most popular method of right now for containers is Docker. It's by far not the only one. I'll mention that a little bit later as we go on, but I'll go through. I'll walk through this slightly. But however, we're building these container images. We have a Docker file, kind of like a make file back in the old C and C++ days, and it's simply instructions of how to replicate the container. Okay, so the other concept we need to talk about, need to touch on real quick, is serverless. So there's this, when the cloud was first became a thing, everybody said, hey, the cloud's going to be great because you're only going to pay for what you use. Well, it turns out that's not quite the case. Let's say you provision a virtual machine or a Kubernetes cluster. Even if you don't do anything with it, you're going to be charged. You're going to be charged approximately 720 hours a month. When Azure was first released, this was a problem because everybody went out and tried Hello World and then didn't shut it down. And then a month later got bills for about $100 for Hello World that was sitting there doing absolutely nothing. So actually what it is more in the cloud, or at least before serverless, you pay only for what you provision. All right. Serverless is an application model, and with it, there is no need to manage or provision servers. You just bring your code, like it says here. And one of the more popular examples is the functions as service model. And there's one of these in Azure called Azure Functions, and the idea is that you aren't charged unless your function, your code, unless it actually does something. So provisioning and deployment are essentially free. Put an asterisk by that because it's not completely true, but there's this idea of scale to zero. Now, the function model is measured in something, or at least as far as Azure, and I think Lambda and Google Cloud Functions do this as well. However, it's measured in something called a gigabyte second. And this gigabyte second, what it is called, is the amount of compute needed to run a function that consumes 1 gigabyte of memory for 1 second. So just do some simple math. You take the number of seconds that your function runs, you multiply it by the amount of memory that your function used, and that's how much you're billed for. So 3 seconds of runtime, so 3 seconds of execution with 1 gigabyte of memory, 3 gigabyte seconds, and 10 seconds of runtime with half a gigabyte of memory is 5 gigabyte seconds. So if your function or your code, if it's not running, if it runs for 0 seconds, well, it can't be consuming any memory. So this is what we call to scale to zero. And there are several models within servers, but there's one called consumption, and all these concepts are going to carry over to Azure Container Apps eventually. And as we get through, and it's called consumption, and this is the one where you literally pay only for what you use, and that's when you can scale to zero. There are also some premium plans in which you have an instance that's always running, so you don't have a cold start and you can run longer functions, but you'll still get the deployment and scalability advantages. Now you can also, you're not just limited to compute for serverless, you can also have serverless databases. For example, Cosmos DB. is one, and also Azure SQL have serverless models as well. Cosmos DB, for example, you can sort of similar to a virtual machine. You can say, hey, there's something called provision throughput, measured in something called a request unit or RU, and what is it? That's like the amount of compute that it takes to read one kilobyte of data or something close to that. But however, you can say, okay, I want 400 RUs so I can per second, so I can read up to 400 kilobytes of data per second. And then, but if I'm only reading 200, now if I'm only reading 200 kilobytes of data per second, I'm still going to pay for 400, much like in the way of a virtual machine. Hey, if you provision 2 virtual CPUs and 8 gigs of RAM, but you don't need that much, guess what? You're going to pay for it anyway. And but however, you can also use a serverless model with Cosmos DB, and it's just kind of how many ever RUs you use, that's how many you pay for, and the RUs that you don't use, you don't pay for. You just only charge for the request units used when actually reading and writing data. So let's take a look at actually this slide is no, it's not. So let's take a look at how containers can be implemented on Azure today. So first of all, we have the DIY approach, and this is the extreme. So you could just spin up a virtual machine on your own. You could do something like you could install Kubernetes on it, but you're going to be responsible for everything having to do with that virtual machine, other than the bare bones, other than the bare metal, other than the infrastructure, the hardware itself. So creating all the nodes in the cluster, the control plane, which is which is like the traffic cop for everything in Kubernetes, handling the node machines, the machines that make up the cluster. You're going to be responsible for absolutely everything. Now, Microsoft saw this as a problem, so they began to offer different container services on Azure, and they came up with one called Azure Container Service. Now, this one was based on, you could use Docker Swarm, which is kind of like Kubernetes, except it's specifically for Docker. It's been a long time since I've used Docker Swarm, but that's how, and I didn't really ever use it that much, but that's how I understand it. Because Kubernetes supports more than just supports runtimes other than Docker. Then there's one called Mesosphere, which I have never even touched, but I understand it's quite complex. And then don't quote me on this. I believe Kubernetes may have been added after the fact, but I know that at one time it did support all 3 of these. This was announced in 2015. And then they announced the Azure Kubernetes Service, which we'll talk about here a little bit more in a minute, in 2017. And then just a year later, they deprecated ACS, and it was sunset, I believe, in 2020. So long story short, Kubernetes won, and but this was Microsoft's first kind of, or at least Azure, their first foray into the world of containers. So let's talk about Azure Kubernetes Service. So this is not quite as extreme as the DIY method of spinning a virtual machine yourself, but this is Kubernetes hosted on Azure. So there's some things that Azure does for you. Now, Kubernetes, again, it's a system for managing, orchestrating, and scaling containerized applications. It supports multiple runtimes, Docker, of course, being the most popular one right now, but it's not the only one. Azure manages all of the maintenance for you. So like I said before, the Kubernetes cluster is composed of worker nodes. You've got the control plane, which is a collection of components, which is going to be responsible for the operations and actions of the nodes in the cluster, things like state and scheduling, scheduling nodes, provisioning them, deciding, what cluster or pod can nodes go into, data storage, and Azure manages a lot of setting this up and maintaining it for you. Like they create the control plane, but you still have full access to the Kubernetes API. So it's not like this is not like Kubernetes Lite. You still have full access to the full thing. So you can use tools like Kube Control, Helm for installing Kubernetes packages and stuff like that. What you do is you bring the containers and you bring the configuration. And you are charged for the nodes that make up the cluster. And again, you are charged from the time that you provision. not from the time that you deploy, and not for the time they actually run. So basically what happens here, it's like Azure does all of the work of the DIY method and then turns the cluster over to you to use. All right. Now, not all applications that are going to benefit from containers need the administrative overhead of managing a Kubernetes cluster. And that's where the Azure App Service comes in. Now, the Azure App Service, you probably know it as platform as a service. In other words, you take a web app, you just take the code and you put it in the GitHub repository or something, and then you tell App Service, hey, pull the code and deploy it as a web application. But Azure App Service also has support for containers. Now, I make this joke all the time. I said Azure Kubernetes Service is great, but it has one major flaw, and that's that you have to use Kubernetes. And a friend of mine one time posted this picture of a real old book. It's about 3 inches thick with the caption says, "Oh, great! My latest complete guide to Kubernetes arrived." And this really isn't a knock against. It's not a knock against Azure. It's not even a knock against Kubernetes, because Kubernetes has a very complex job. It really does, and so it's going to be a very complex piece of software. However, there are advantages of using Kubernetes that advantages of using Kubernetes that you don't need the Kubernetes overhead for. So with Azure App Service, you can take a web app that you developed in a container and you can deploy it to Azure App Service. Supports both Linux and Windows web applications. You're going to be able to support for multiple languages. So Python, .NET, Node, Java, I think Go is in there. There's about a half dozen languages or so that are supported. You do get scalability out of this, so you can run a simple web application all the way up to multiple instances. Continuous deployment. So this is a this is a nice feature for App Service that also you can get out of other services as well. So container images are going to be stored in a container registry, and you probably may have heard of Docker Hub if you've worked with Docker before. And this is an example of a container registry. And Docker Hub is a public container registry. You can pull images from it without a username and password. But Azure also offers a container registry that we'll use in the demo later on. It's creatively called Azure Container Registry, and you can privately host container images there. Another nice feature of Azure Container Registry is the ability to use tasks and hooks to monitor a GitHub repository where the code for an application with a Docker file and everything is stored. And then if a change is noticed, it's going to automatically rebuild the container image for you. Then App Service is going to be notified, and it will pull the latest build of that container image and deploy it to your application. So in other words, you only have to set all this up for deployment the first time. And you could do this with Azure Kubernetes Service, but you're going to have to hook a lot of this stuff up yourself. You can actually use multi-container deployments. That support is in preview right now, but so this is something, if you just need to deploy a web app to a container, this is a pretty good choice. Definitely a better choice than Kubernetes. Well, what if you need something that's a little less opinionated? So, as you saw, the app service with containers is going to make a lot of assumptions about your containers in your app. So Azure Container Instances, this is run Docker. Actually, I need to go back and check and make sure. The ability to run containers, I don't know if they have to be Docker containers. However, the point of this is that it runs serverlessly. So again, you're only going to pay for what you use. So for example, here is exactly how cheap it is. It's this much per gigabyte second. So you run 1 gigabyte. So again, you run that 1 gig that you run your container this time, not your function, but you run your container for 1 second. It uses up 1 gigabyte of memory. That's how much it's going to cost you. With Azure Container Instances, you also pay for CPU time as well. So whereas functions, they just charge you for the gigabyte second. Nice thing about Azure Container Instances is that you have access to GPUs. So you could push machine learning workloads onto these. There is a surcharge for the GPUs. You do not get GPUs for this amount here. That'll be really, really cheap. It's not running Kubernetes. however, is running Hyper-V containers. Hyper-V being the Windows virtualization technology. So that means you can run Linux or Windows instances, Linux or Windows containers or apps. That is, no containers. I'm sorry. Yeah, Linux or Windows containers on ACI. There is a surcharge for Windows. It's a little bit less than the virtual CPU price. You do not get scaling, so you cannot scale. You can scale these, but you have to do it yourself. So if you want to have 5 instances, you're going to have to create 5 Azure container instances and deploy to all of them. This is possibly, however, the most compelling reason to use Azure container instances. So again, Azure Kubernetes Service has these worker nodes, these worker node machines that are part of the cluster. Well, what you can do is you can take an Azure Container Instance Writer and attach it to an Azure Kubernetes, an AKS cluster as a virtual node. And this kind of gives you the best of both worlds. So let's say that you've got your main main application running on AKS, but you have some smaller workloads that you would have to increase your cluster size or capacity for that don't run all the time. You could offload those onto Azure Container Instances running as a virtual node and save yourself some money and some complexity. And let's see here. Let me see here. Let me go into the chat, make sure that. Okay. I sometimes forget to look at the chat, but okay. So where'd my cursor go? Okay. So let's continue on here and let's actually look now at Azure Container Apps and see how it fits into the picture. Now, at first glance, the line between the Azure Container Apps and the Azure Container Instances, it's quite blurred. Before starting off, I'll basically say that the way that the documentation and the marketing material describe Azure Container Instances as lower level building blocks that are less opinionated. And we'll see why here with Azure Container Apps. So Azure Container Apps, they abstract the complexity of Azure Kubernetes Service. Remember, Azure Kubernetes Service and Kubernetes in general, just really, really complex, but not every application needs that complexity. In fact, Azure Container Apps run on top of Azure Kubernetes Service. Now, unlike Azure Kubernetes Service, with container apps, you do not get access to the API. I would say probably most of the functionality again is abstracted away from you. It is serverless, like Azure Container Instances. We'll look at the pricing here in just a minute in more detail. Auto scaling, which Azure Container Instances did not have, but Containers for App Service did. So you can use any Keta scaler. Now, Keta is, what is it? It's Kubernetes event-based. No, Kubernetes event-driven auto scaling, and it's basically a metric of some kind, like HTTP traffic or I'm drawing a blank. However, there are several. If you go to the Keta website, keda.sh, you'll see a number of these scalers. There's like, I forget how many of them there are offhand, but there's about a dozen or so that are specifically for Azure. And so things like, you can say, hey, for blob storage, when you have so many blobs that are waiting to be processed, maybe we need to maybe we need to scale the container up to handle that processing, or there's so many messages in the event bus or something like that. You can scale to 0 or almost 0 with the consumption plan, and most scalers, if you're one of the scalers that you can use is CPU or based on the CPU or memory usage, and you can't scale to 0 with those, because the only way to scale to 0 with those would be to have absolutely no CPU and no memory usage, and that would mean you were completely turning your application off. But there is a consumption plan similar to Azure Functions, and you can scale to 0 with it. Traffic splitting. This is something that in the demo can show you at least the interface for. It's kind of hard. It's kind of hard to demo, but the traffic splitting. So you could do something like A/B testing or blue-green deployment and split your traffic up, not necessarily among instances among replicas or replicas of the same container, but different revisions of the same container. Get virtual networking for free. You can bring your own virtual network as well. Secret management, I'm not particularly a big fan of the way secret management is done right now. However, in preview is a way to do secret management that's very similar to how Azure functions and how Azure Web Apps or how Azure App Service rather does this by working with Key Vault. Right now, for Key Vault, you have to actually write code in your application to access the SDK, the Azure Key Vault SDK. Whereas with functions and app service, well, functions, I know it works this way. I haven't done this with app service for a long time, but with functions, basically you create a managed identity for your function app, and then and then ask, and then tell the Key Vault to give permission to that identity to access the secrets, and it's all just in configuration after that. You don't have to put any code in your application, and that's currently in preview for container apps. Logging comes for free. And then you have management support. You can manage this with the Azure portal, which is mostly what I'll use today. You may hear me complain about it because I actually don't like any of the portals for the web providers. I just dislike Azure's a little bit less than the others. So I may stumble around there a little bit. You can use the AZ CLI, which I was talking to Bill about before we started. It's written in Python. You can use our Azure PowerShell, which is actually what I'm kind of moving to. I'm I'm trying to be kind of a unicorn in that I'm going to use PowerShell on Linux, and also ARM and Bicep templates. There's ways to configure Azure Container Apps there. There is also an extension for Visual Studio Code. I didn't put it on here because I don't really like it. There's some it works and it gives you the ability to do some management tasks and some monitoring tasks. We can take a look at it when we get to the demo if you like. And another nice thing about Azure Container Apps, it is free to get started. There is a free monthly grant. So let's look at the pricing. And that's going to come in the form of a plan, much like app service and functions. You have to have a plan, which is going to determine, among other things, how much you are billed. So let's take a look at the pricing here. So you have the consumption plan, which again is very similar to the functions consumption plan. You pay only for what you use. Now there's a little bit of a difference here. Like Azure Container instances, you are charged for CPU time, and here's the price. That's when it's actually running. However, you're also charged for virtual CPUs when you're idling, and it's almost, I mean, I don't know how, I haven't calculated that, how long you would actually have to run idle before you actually started to see anything significant. And then that actually is wrong. That should be gigabyte second, because this is the price for memory, and it doesn't matter whether the app is active or idling. You're still charged that same price. And then you're also charged per million requests. So it's 40 cents every request that comes into that container app. You'll be charged per million of them, charged 40 cents. Like I said, you get started for free with monthly grants. So 180,000 virtual CPU seconds, 360,000 gigabyte seconds. You also have free grants for Azure Functions, which I believe is 400,000 gigabyte seconds, and I think they may only give you 1 million requests. I don't remember, but for Azure Container Apps, 2 million requests, and that, again, that's every single month. And this is something. This is not you. I mean, you have to sign up for the free trial, but this is not one of those things that expires after 12 months. This is something that is going to be. This is something that is always free. There is the dedicated plan, in which you're going to pay for dedicated instances, very similar to the premium plans of the functions, but you'll still get all the other advantages: the scalability, traffic splitting, logging, and everything. And then there's also this preview consumption plus dedicated plan, which allows you to scale to 0 with the asterisk by it, but you can optionally have dedicated and customized instances for more intensive workloads and such. Okay, so every single so an app container, so every Azure Container app is going to live in an environment. And this is they call it a virtual boundary. And so this is so everything that's in the environment, you're going to have, it's going to share a virtual network, you're going to share logs, some other things for all the apps that live in the same environment. So this is a picture that I stole from the documentation, and it shows basically the idea of how these environments work. So so you have multiple container apps within your environment, and then you have in the containers, which can be the containers which can be replicated and scaled, live within those container apps. And then there's the containers themselves. So in most scenarios with containers, you're only going to run a single container per app. This is especially in the case of the microservice scenario. You're not going to do like a Docker Compose situation or something. You can do that, but it's something that you generally don't need to do. If you have multiple containers, you're going to have a separate app. You have a separate container app for each container, and then you'll be able to scale that container up and down within that container app. But the container app itself will run just a specific part of that application. And then there's a way to not gonna be able to don't have time to demonstrate it tonight, but then there's a way that you can have the containers communicate privately with each other. Again, running multiple containers in a single container app, it's an advanced scenario. It's needed only when accessing resources that are shared at the container level only, and not within the environment. Now with containers, you can only run Linux containers. You cannot run Windows containers in Azure Container Apps right now. And also everything in your, it's also, you cannot run what's called a privileged container inside of Azure Container Apps. So if you try to do something inside of a Azure Container Apps, inside of a container rather, that needs root permission from Linux, then you're not going to be able to run that in Azure Container Apps. It'll crash. So a couple of other things about containers before we go on to revisions here. You can pull these in from any public or private repository, any base image. You don't have to use a specific base image. So basically anything that you can do with Docker on the desktop, outside of, assuming that it's Linux and doesn't need root permissions, you can run in Azure Container Apps. They automatically restart if you if they crash. And then let's see here. Yeah, that's about all I wanted to go over. Okay, so let's talk about revisions. Now, is a snapshot basically of a container app, an immutable snapshot of a container app. So if you create, so when you create the container app, obviously it's going to create a revision. But if you deploy a new version, or you update a container, or if you deploy a new container to that container app or update the container, it's going to create a new revision, and it'll store these, and you'll be able to run actually multiple revisions at the same time. Remember that you can split traffic between these and do like A/B testing. So if you have if you have two revisions that have significantly different features, and you want to do the A/B testing on them. You can revert back to earlier snapshots, kind of the blue-green deployment scenario, and you can have up to 100 revisions at any time. And I'll show you how you can show you some of the revision management when we get to the demo. And this is again another something else that I stole from the from the documentation, that's showing the containers. If I can find my cursor, showing the containers live inside of the revisions, and then of course the revisions live inside of the app, and then bubble back up to the top. Okay. So let's see here. This is another slide that I often steal from the documentation when talking about this. Talking about some of the scenarios that you can use. Microservices, again, is probably the one that this is intended for, but running APIs, HTTP APIs, REST services, and then background processing, event driven, and then showing here some of these features such as HTTP traffic, HTTP splitting, using the K to scale triggers, Here you can scale again by the number of messages in the queue, like talked about before, CPU or memory usage, or the number of HTTP concurrent HTTP requests. What in the world? No, go away. There we go. All right, so with that, that took about half an hour, so that's good. So let's take a look at a demo. All right, let's see here. Let me get my notes for the demo up here because there are a number of steps and I want to make sure. Any questions first? Any questions first?
Yeah, if you have questions, put them in the chat.
Yeah.
Okay.
Okay, so where are my notes for the demo? Because there are a lot of steps, there are a number of steps here. So first of all, what I'm gonna do is I'm gonna go over here to Visual Studio Code. And I've got this little Python app here. I'm not going to go through what it does because it's irrelevant. It's just a little API that will manage a portfolio of cryptocurrency investments. Is all it is. So I can run it. I can run it locally here just to. So Unicorn app API --reload. It's going to run here on port 8000. Bring my browser over. And Fast API has a nice feature that if you go to /docs, you're going to get this Swagger-like interface for your API. So I can go down here to this one where I could create an investment, try it out, and I'll say, okay, I'm going to buy Bitcoin 1.3, buy equals true versus sell equals false. And then if I execute this, I'll get the object that's stored on the server. Actually, this is a Cosmos DB database running on Azure with the MongoDB API. And once it's been inserted, it'll come back with this object ID, which is an ID that MongoDB will attach to the object. And then if I go up here to get all investments, then it'll get all of them. Right now, there's only one, and I could also get them just by get only the investments for a specific coin. All right, so that's the extent of the demo app. Let's take a look at how we can get this into a container. So I'll kill this, and notice I've got this Docker file over here. And this Docker file, actually, this is the one you can, if you have this Docker extension for Visual Studio Code installed, which we'll look more at later, if you've got you can go in here to the command palette and tell it to add a Docker file to the workspace. And there are several here that are they're pre-configured, several Python, several for Python, Node, Java, Go, .NET, Ruby, if you absolutely have to use Ruby. And it'll generate this Docker file for you. And so the Docker file, like I said, that's instructions on how to reconstruct or replicate the container. Or rather the container image, how to build the container image. So here we're going to be starting from a base image that has Python 3.10 installed. Since we're running a network service, then we need to expose a port. It's going to run on port 8000 inside of the container. So we'll expose port 8000 to the world. Some instructions for doing some things in Python. Here's how, remember I talked about, the dependencies are going to be packaged with the container. Here's how we specify and install those dependencies using Python. Here's where we're actually going to copy the code for the app. This is actually not necessary generally, but it was generated. And then down here is the command for the entry point for starting the application up. And then there's a Docker ignore file also, which is a lot like a git ignore file. Whereas git ignore says, hey, this is what you don't include in the Git repository. Docker ignore says, hey, this is what you don't include in the Docker container. All right, so let's build this container. So we'll just do Docker build -t. This is for tag, and the tag is generally the name of a name that you choose plus a version of some kind. So I'll just say v1 here, and then a location for the Docker file. I'll just say dot to say that the Docker file is in the current directory. This is going to be really fast because I've already run this earlier on the machine. So all of the necessary parts that it would have to pull down, it would otherwise have to pull down from the interwebs are already cached on my machine. So if I go over to Docker and I look at my images, again, what we've built is we built an image. You're going to see that we have this NV Azure image tagged with V1. It says 2 hours ago. It's probably because I haven't changed it from the last time that I did this. So any rate, it should, but at any rate, this will, it's there. So now I can run it and run it I'll run it locally. So Docker run -D to run it in the background, -P to expose port 8000 on the container to port 8000 on the host, and then the name and tag of the container itself. So this is the ID that's going to, and notice it returned immediately because it's going to run in the background. However, if we look up here, we see that we have this this container actually running. So again, this is the image, this is the container, which is the actual instance. And if I go back over to my browser, it's going to look like nothing, it's going to look like nothing changed here because I'm still running localhost 8000, but this time this 8000 is forwarded from the container, and it will still work as usual. You'll still see the same Bitcoin investment that we created earlier, because again, this is just running on, this is pulling everything from that same Cosmos DB database. So I could go ahead and add something like Ethereum, and we'll get some Ethereum, and then execute that. And then I'll sell some of that Ethereum because later on, in a later part of the demo, that'll become important. Okay, so now we've got 3 investments here. Just for sanity check. Again, this is running the PyMongo API for Cosmos DB, so I can use any Cosmos DB, so I can use any any MongoDB tool. For example, this one here, that is an Azure extension or Visual Studio Code extension, and you can again see that indeed those are being stored. So it works. So what we've established now is that this works inside of a container. And the Docker extension lets me do things like lets me manage. So I can start, stop. I could attach to the shell, so I could shell in, kind of remote into this container. But for now, I'm just going to stop it so I don't have any port conflicts. Okay, now I really need the notes, because this is where we start messing with the Azure portal. So I'm going to go into the Azure portal, and I've already got a resource group set up with that Cosmos DB account in it. And I'm going to, so I'll go back home and I'm going to create a container registry. You don't have to, again, you don't have to use Azure Container Registry, but you know, as an MVP, when I talk about the cloud, it's going to be an Azure commercial. So I'm going to create no, I'm not going to create a new resource group. I'm going to use the one that I've already got here. And then I'm going to give it a name. So I'll give it NV Azure CR. I'll put it in a region. Come on. East US there. That's what I wanted. No, I want East US. I think I used East US before. Okay. And then the SKU, this basically it says how much things like how much storage are you going to have, what kind of bells and whistles, such as webhooks and stuff. What is the basic one is, I think, about $5 a month. The standard one is about $20 a month. $20 a month, and then the premium I forget because I've never used it. You can actually get the standard tier free for 12 months if you sign up for the Azure trial. But then I don't need any of this stuff, do I? No, I don't. Okay, so I'll go ahead and create that. That'll take just a few seconds. In the meantime, I can actually go back to Visual Studio Code and retag this image over here for Azure. So this is a requirement that that you have to retag this image before pushing it to the container registry. So what you have to do is you have to say Docker tag, and then say which container you're going to be retagging. So I'm going to be retagging NV Azure version 1, and then you have to take the and you have to do this in a specific format. You have to take the URL, the address of the container registry, which in this case is going to be right here, the server address rather. And also, by the way, you can also spy on your registries over here in, you can also spy on your registries from within Visual Studio Code. Right now I don't have any containers in there. And then but however, then the name of the container in the Azure v1. Then I can push this to the repository. So that's actually just going to be in the Azure cr dot Azure cr dot io/nv underscore Azure. Okay. And you're going to see if this is pushing all those oh, I left out a step. I knew I would. This is why I have notes. You have to log into the container registry first. So Azure ACR login, and then the name of it, which again is in the Azure CR. Okay, now I should be able to do that. There we go. Now it's going to work. Now this actually hung on me a few minutes ago, but it looks like it's going to work this time. Okay. You never know kind of after hours what mood Azure is going to be in. Okay, so now I can go back over to the repository. I can refresh this, and you'll see now that I am actually using a very, very small part of my storage. But if I go into repositories, you'll see that I do indeed have a container in here, this v1 tag container. Okay. All right. Now there's one other thing that I have to do in here is so that you can access this registry from Azure Container Apps. I need to go back over here to access keys and enable this admin user. This is kind of one reason why I don't really like the portal sometimes. It names things weird. And just also outside of that, just the obvious information overflow. This is one reason I have to have notes is to look for admin user under access keys. To me, that just makes no sense. But at any rate, it does work. So let's go back home now and let's go to Container Apps, and we're going to create a new container app. And I'm going to create that again in my resource group that I had before. The container app name, as you see that I ran through this earlier today, so I'll just use what I've already got there. I'll bring I'll say US East. Actually, earlier this year, it looks like they've taken that feature out. Maybe people didn't like it. Azure had added the feature of where every time it wanted me to select a region, it thought I was in Canada. But at any rate, I'm going to go over here. I need to create. I'm going to give this environment a name. So let's see here. Say NV Azure CRENV. And here's where you can choose. And here's also where you can choose your plan. Okay. So again, this container app named this is going to live in this environment named this, and then we actually select the container that we're going to deploy the first time. There's another reason kind of weird with the portal is that it wants you to use a some kind of hello world image for the first deploy. But if we uncheck that, we can we can put the container details in. So this is the container that I want to use. I want to pull from the Azure Container Registry. If I had Docker, if I wanted to use Docker Hub or another registry somewhere, I'd have to enter the server credentials and such. But since I checked that, since I enabled that admin user in the container registry earlier, Azure Container Apps can now see it. So I'll select that. Here's the image. It's the only one, and the tag. Here's also where I could say, you know, I want to allocate more memory and CPU. Environment variables if I wanted, but I don't need any of those, so I'll go back here. I want to go to ingress and enable that because I do want to access this via HTTP. I want to accept traffic from anywhere, and the target port again, 8000. I think that's everything. Yep, everything that needs to be done. So now I can go to review and create. And I think this should only take a few seconds. This generally takes about takes about a minute to do this. If I didn't skip a step. And everything else that we want to talk about. Well, let me see here. Well, this is, nope, here we go. Okay, so shouldn't be too much longer. Either I'm doing a really good job of explaining or a really bad job of explaining, everybody's falling asleep because there's no questions in the chat. Okay, there we go. So that's done. So now I go to the application, go to the resource, it'll give me a URL. And if I hit that URL, there we go. We can see the default page. But if I go to docs, I'll see my Swagger interface and again, try it out. And we'll see those three investments that are coming from Cosmos DB. A couple of other things to look at in here. So first of all, one of the things to talk about is the scaling. So if you want to go work with the scaling, you can go over here. Right now, there are no scaling rules, but you could set, for example, if you go over here to scale, you can set the maximum number of replicas, the number of times this container can be reproduced. Again, here's 0, so it'll scale down to 0, a maximum of 10. If I wanted to add a rule, go over here, give it a name, select a type. So here we have, there are 2 that are predefined. So HTTP scaling, the default is 100 concurrent requests per second. So I could go to 200. I could add another one here. I could add a custom one. This is when you're going to have to go through, you would have to go over to kata.sh. And you can see, let's see here, scalars. And so, yeah, there's 61 scalars available. Like I said, here's one. So like I said, here's one for Azure Blob Storage. It would be dependent upon the number of blobs that you had in a blob container. This would be kind of arduous to do through the portal. So you'd have to copy that type in, which is not a big deal, but then you have all these metadata values that you would have to also add in. You can actually do this using other methods, like an infrastructure as a service template or something. So something like ARM or Bicep, you could put these in a configuration file and have them uploaded automatically. But that's how you would manage the scaling. Also, when you create a scale, when you create a new scaling rule, notice that it's going to deploy a new revision. This only takes a few seconds. So we'll go ahead and let it do that. And then we can see what some of the things about what revisions look like. Okay, so see it deployed the new revision. So if I go over here now to revision management, you'll see that I have those 2. They're both running. Although the most recent one is receiving 100% of the traffic. So this is where I could also, so if I forgot to do something else. I have to have that in there. So, but at any rate, when this updates, I would be able to modify this, and so I could split the traffic between these 2 different revisions. In this case, it wouldn't make much difference because they both do the same thing. Could assign them a label and such. Give this just a few seconds. Okay, so now I could go through and I could split these 50 it will complain at you if the total traffic does not equal 50/50 when you save it. You can look at you can get details on the different containers. Of course, here you see that we've got the image and the tag coming from that registry that we created. Environment variables that you could put environment variables in there. Here's where you can store these secrets. in a manner that is specific to the container app itself. You don't want, again, like I said, I like to use Key Vault, and that integration is coming. Here's continuous deployment. I talked about the continuous deployment. I believe it was with web apps. Here's where you can set up integration with GitHub apps with GitHub Actions rather to automatically build and deploy the container every time there's a push. Dapper, if you're into Dapper, there's again, talking about microservices is one of the things that Container Apps is really intended to do. So Dapper is in there. This is this is something that, again, it's in preview, something that's going to be a way to connect to an easy way to connect to other Azure services. Here's all of your logging. Just and then some other things in here that I actually have. The authentication, I've never really messed with the authentication in here. Ingress, so that you can again change how it can be accessed via network. You can add a custom domain if you want. Lots and lots of different things in here. But before I run out of time, let's look at what happens when you update a container. So I will go back to, see, I told you I wanted to move to Nashville. And so I'm going to go back to my code. And again, I'm not going to explain the code because again, it's irrelevant, but I have a change here that I'm going to make. And what this will do is, instead of just returning a list of the investments that are stored, it will total up how much of each investment we have. So it'll total up all the buys and all the sells, subtract the sells from the buys for each coin. Then it'll go out to CoinGecko, use an API to get the current price, and it'll return the total value of each investment. So real quick, let's see what that's gonna look like. So we'll say again, run this locally, Uvicorn, app API --reload, and I go to, you can already see a preview of what it's going to do there. Docs. If I say get all investments, this time it's going to return me the values, again, live prices, but not just a list of the investments, but the values. So let's put this into a container. So let me go up here and find this. Here we go. I'll build this one to be V2. If we go over here to Docker and look at our images, we'll see now that we have a V2, and I can run that. Now we know what's going to happen if I run it, so I'll just retag it and push it to Azure so that I don't run over time. So I'll do that with V2, and then I will push V2 to the container registry. And if we look here, we have V2. Nope, I'm sorry, I want the registry. So if I refresh the registry, see that I now have both those tagged images. And if I go back to, I lost my portal. There we go. And if I go back to my container app and go to my revisions, I can say I want to create a new revision. And maybe I want to give it a name. I'll say V2. And I could go in here and I could do things like I could modify the how much memory and CPU space I'm taking, or CPU usage I want. But I can also get create a revision with the new tag now, put environment variables if I wanted to, create this, take just a few seconds. Now what I could do is this one that I just recently created. I could say 100. I could allocate all of the traffic to it. Now save this and it'll do one more update. And now if I go over to my overview and go to the URL for the container, for the container app. And now you'll see that it's running that second version of the container, the second revision of the container now, because we're getting the totals back and not the list of investments. So that's, like I said, that should at least get you started and see how easy and quickly you can deploy and manage containers and container apps. So real quick, I will go back to these slides if I can find the window. There it is. Okay. So what's coming up? These are preview features. And when Bill asked me actually if I could do this talk last month, I said, no, I'd really like to do it in June, because what was going to be announced at Build that I couldn't talk about yet. But there's something called Azure Container Apps jobs. Right now, what I've talked about tonight is the Azure Container the apps are meant to be running for, at least extended period of time. It's not meant to start up and shut down really fast. Container app jobs, think of them kind of like cron jobs. They are containerized apps that run for a finite time, and then they exit and you don't need them. So you can do these, you could trigger these manually. You can set them up on a timer, again, like a cron job. Event-based, similar to Azure Functions. That's one thing about Azure Functions is that how do you invoke that? How do you invoke that code? It's an event based, such as an HTTP request. You could use a timer, say a change in a Cosmos DB document or something like that. So in a way, this is, well, I don't want to say that this is like, no, I don't want to say that. So, but like I said, this is a way that you can take a task that needs to be handled by a containerized app and that just runs for a finite period of time. You can also, this is also in preview, you can run functions in Azure Container Apps. Now, this is interesting because you can deploy functions along other microservice components. So you could have kind of, I don't want to abuse the word hybrid, but you could have microservices that are made up of multiple service types, multiple Azure service types. So you could have container apps, and you can have functions running, beside of them, so you could get the best of both worlds. Again, Dapper is a big thing there. You get a lot of the advantages, such as the Kata auto scaling. And then and this also works on the consumption workload, so you can scale down to zero, if not close to zero. Let's see here. That's all I've got. We've got what I wanted to go for about an hour, because I think I started talking about 6:15. So I can stick around for a while if anybody wants to have questions. But in the meantime, if you'd like to contact me, there's my link tree. I've got about, I think I've got 8 different methods that you can contact me on. Let's see here. Let's see here. So what does Stephen ask? What does the revision do again in purpose? So the revision is whenever you deploy a new version of a container, update a container, deploy it, redeploy a container. Whenever you make a change to something like a scaling rule, what it's going to do is whatever the most recent version is going to take a snapshot. Again, it's an immutable snapshot, and it will create a new revision for the deployed for the one that you've just deployed for the updated version. And like you saw in the let me see here if I can get back to here, my revisions. As you can see, it's going to keep all of those revisions that when you create them, unless you deactivate them. And this is how. So if you've got, like I said, if you've got 2 different revisions, each running a version of your application with different features, that's where you could do your traffic splitting. So you could do your A/B testing. If you deploy a new container and, hey, there's a bug in it, okay, I need to go back to the previous version. Those are two reasons. Also, again, remember that when creating a revision, you can have different You can change the amount of CPU and memory that you're using. You can change the scaling rules for a revision. Okay. Let me see here. There we go. Okay. Yes. In the context of Azure Container Apps. Yes. Well, so thanks everybody for your time this evening. I hope that was helpful. If you want to, if you have anything else you'd like to see, let me know. I've got content on other developer topics. I'm not really an administrator of Azure, but I do developer topics, but I do a lot of developer topics with Azure. And come join us in the Python user group on
Hey,
Monday.
great. Thanks a lot, Doug. Excellent presentation.
Thank you.
A lot to absorb.
Yeah, I have a rather notorious reputation for compressing a lot into a short amount of time, which is why I tried to constrain myself to an hour.
Right. We very appreciate it.
Well, thanks for having me. I enjoy doing this.
Okay, thanks a lot. I'm going to wrap up.
Okay.
Let's see if I can find the right button. They changed the interface.